Hello and welcome back to Zig's Math Lessons. This is where we put it all together. Combinations of transformations. Everything we've been doing lately all happens at once. Now, let's try this. Example 1. The graph of y equals f of x has had the following transformations applied to it. Reflection in the x-axis, horizontal compression factor 2, shifted left by 1 unit, and up 3 units. State the equation of the resulting function. Solution. Well, we can start with y equals f of x, and then we have to reflect it in the x-axis. So we have to replace y with negative y, and there it is reflected in the x-axis. Now, horizontal compress factor 2, that means we have to go into the input station because it's horizontal motion and compress, so we'll put a 2 here. There's our horizontal compression factor 2. Now shift left by 1 unit. I just copied it up here to show you this. This is wrong. We need to put into brackets with the x. It needs to go left by 1 unit. Well, this isn't in brackets with the x. This is. So this is right because this is left by 1 unit because there's brackets around the x plus 1, while this is wrong because the brackets don't include the 1. So we'll do it like this, left by 1 unit and up by 3. And there it is. Y equals negative f of 2 times x plus 1 plus 3. Let's go again. A brief discussion about order. Well, I wonder if order matters. Suppose we had a point P and needed to horizontally stretch it by a factor of 2 and shift it right by 2. Does it matter if we do the stretch first or the shift? Well, let's consider. If we do the stretch first, so we have to stretch it by a factor of 2 and then shift right by 2. So stretching horizontally by a factor of 2 makes the 3 turn into 6. And then we have to shift right 2 and we end up at 8. It ends up at 8, 0. Now let's do it in reverse order. If we do the shift first. So we'll start again with the point at 3, 0 and shift it to the right 2 first. And now we have to do a horizontal stretch. So it's 5 to the right and double that. It goes to 10 to the right. And it ends up at 10, 0. So it does matter which one you do first. It ends up at a different spot, so order of transformations does matter. And the correct order is to do the transformations from left to right as they appear in the transformation equation. The vertical stretch first, then the horizontal compression, then the left-right shift, and then the up-down shift. Example 2. Describe the transformations that must be applied to the graph of y equals root x in order to graph y equals 3 root negative 2x plus 10 plus 4. Solution. We need to rewrite the function. The reason is that in the transformation equation there's a positive 1x in round brackets. Now this is not a positive 1x. It's a negative, and it just happens to be 2x. But even if it was just a negative x, we would still have to rewrite the function so that there's a positive 1x underneath this root sign. So the rewrite involves common factoring out the minus 2 by inserting a bracket around the x, like this. We factored out minus 2. We should check our work. If you write a line and you have any doubt, check it. If you multiply this out, we get the minus 2x like we must, and we get plus 10, which we must. So this is correct. And we can identify the correct transformations from this. Starting from the left and going to the right, the first thing we encounter is a 3, and that's a vertical stretch factor. The next thing we encounter is a negative sign on the x. Now this negative sign will be multiplied onto that x. So x got replaced with negative x, reflecting the y-axis. This is a horizontal compression, factor 2. And this is a right 5 and up 4 shift. Putting them all together into one. Next, let's graph. Y equals negative 3 root negative x minus 4. Solution, you'll have to do the rewrite. This rewrite is necessary because this is a negative x and we need a positive x in brackets with the left-right shift. Once you've rewritten the function as necessary, list the transformations from left to right. So the first thing we encounter is a negative sign, so that's a reflection in the x-axis. Reflected in x-axis. The next thing we encounter is a 3 factor on the radical, so that's a vertical stretch times 3. The next thing we encounter is a horizontal motion, which is a reflection across the y-axis. So reflect across the y-axis and then shift left 4, because that's the number in brackets with the x, and we know that a plus sign means left. Shift left 4. So what have we done? We've rewritten the function and we've listed the transformations. Next, consider the parent function being y equals root x, the top half of a parabola that opens to the right. It's the parent. And let's follow the points. Let's follow this point, the vertex. So we'll take this vertex from the parent function and we'll go down the list. Reflected across the x-axis, it stays put, like the groundhog drinking from the shoreline. Vertical stretch times 3 means multiply the y value by 3, but the y value is 0, so it stays put under the vertical stretch. And it also stays put under the reflection in the y-axis as well. So for the first 3 transformations, the origin is, in this case, invariant. Then it shifts to the left 4 units. Okay, we have to shift it to the left 4 units and put a point right there. Next point, next lattice point on the parent is 1, 1. Let's go down the list and apply them to this point. First of all, reflecting the x-axis, well, it goes across the x-axis to here. Vertical stretch times 3, it's 1 below, so it has to go 1 times 3, 3 below. Reflecting the y-axis, so it has to go across the y-axis. Then it has to go left 4 units. 1, 2, 3, 4, and put a point right there. Let's go to the next point that we know about on the parent function, which is 4, 2. 4, 2, because 4, root 4, which is 2. And let's take our eyes and go down this list. Reflecting the x-axis means it comes down here. Vertically stretched times 3 means takes the y value, which is minus 2, and multiply by 3. Make it minus 6. Minus 2, minus 3, minus 4, minus 5, minus 6. Reflect across that y-axis. Now this is 4 to the right of the y, so we got to go 1, 2, 3, 4 to the left of the y-axis. And then from here, with my eyes on the list, it says shift left 4. So 1, 2, 3, 4, and put a point there. And finally, on our parent function, we have this point 9, 3. With our eyes on the list and our pencil on the point, reflect in x. That's 3 above x, so we have to go to 3 below x. Vertically stretch times 3. 3 below, triple that, make it 9 below. That's 3, 4, 5, 6, 7, 8, 9 below. Reflect in y. Well, I'm 9 to the right, so I have to go 9 to the left. 2, 3, 4, 5, 6, 7, 8, 9 to the left, and then shift left 4. My eyes are just going down the list of transformations. 1, 2, 3, 4, and put a point right there. Join them together, label your curve, and you've graphed y equals -3 root negative x minus 4. That's the procedure for graphing. Let's go again. Example 4, graph this one. Well, that's the parent. The parent function is 1 over x. And we note that we can see the parent buried in here, because if we factor out this 2, it says 2 times this, and we can sense this is 1 over x shifted left 3, vertically stretched times 2, minus 1. Let's list the transformations, left to right. Vertically stretched times 2, shift left 3 and down 1. Now, since this one has the asymptotes, we deal with them first. So shift the asymptotes to the left 3. So we'll put an asymptote here instead of the y-axis, because that's 3 to the left of the y-axis, and down 1. So this would be the x-axis shifted down 1. So there's our new asymptotes. And now we just have to pretend that this is the origin and graph the parent function, but we have to be mindful of the fact that points are vertically stretched times 2. So let's go to 1 from our pretend origin. We go to 1, 1, but we have to multiply that 1 by 2. So it'll be 1, 2, and we put a point right there. Next, we'll go 2 to the right, and then 1 over 2 doubled, because we're multiplying by 2. So 2 over, and then a half, doubled is 1. So 1 up, and a point goes right there. Over 3, up a third, but double that, up 2/3. And over 4, up a quarter, doubled is up a half. And we can go over a half, and we're supposed to go up 2, but we have to double that because of the vertical stretch. So it goes all the way up to there. So there are some points on our one branch, and we just have to do the corresponding points on the other branch. So we'll go -1 down, 1 over 1 doubled, so that's 2 over 1, which is 2. Go over 2, down a half, but double that, so down 1. Over 3, down a third, doubled, so down 2/3. And over 4, down a quarter, that's 1 over 4, but double that, 2 over 4 is a half. So a point goes there, approximating. And now we'll go left a half, and we're supposed to go down 2, but we're also supposed to double that. So we'll go down 4 instead. So over a half, down 4, all the way to there. And that's how we achieve the vertical stretch. First, we rearrange the asymptotes, and then we make sure that we apply the stretch, join our points together, and label your graph. Y equals 2 over x plus 3 minus 1. Here's another example. Given y equals f of x, some funny looking graph. Graph y equals -2 f of a third times x plus 2 plus 1. We'll list the transformations. Reflect in x, left to right. The first thing I encounter is a negative sign. Reflect in x-axis. Vertically stretch times 2. Horizontal stretch, because when you divide by a third, you multiply by 3. So this is a horizontal stretch, because the number is less than 1. Putting it all together. And now we'll have to shift left 2, up 1. So let's apply this list of transformations to these corner points. We'll go to the first one with my eyes on the list. Reflect in x. So 3 above goes to 3 below. Vertically stretch times 2. So I'm 3 below. Make it 6 below the x-axis. Horizontal stretch times 3. Well, I'm 2 to the left. Triple that, or multiply that by 3. Make it 6. Now I'm 6 to the left of the y-axis. Shift left 2, and then up 1. And a point goes there. Let's go to this next vertex point, corner point, with my eyes on the list. Reflect in the x-axis. It stays invariant. Vertical stretch, it stays invariant. Horizontal stretch, it stays invariant. Simply shift left 2 and up 1. And a point goes there. Go to the next corner point. Reflect in x. Goes down to 1 below the x-axis. Vertical stretch times 2. So I'm 1 below, make it 2 below. Horizontal stretch times 3. Well, I'm 2 to the right of the y-axis, and I'm moving horizontally. So let's go 2 times 3 is 6 to the right. So 2, 3, 4, 5, 6 to the right. Shift left 2 units and up 1. And a point goes right there. The next point is the vertex of this parabola portion, which is right here at 3, 3. Reflect in x, it's down here at 3 minus 3. Vertical stretch times 2, make that 3 minus 6. Horizontal stretch times 3, so I'm 3 to the right. Make it 9 to the right of the y-axis. Shift left 2 and up 1 and put a point there. That'll be the vertex point of a parabola type portion. And finally, the very end one, where we paid attention to each corner point and vertex point. Let's pay attention to this one. Reflect in x, down here, vertical stretch times 2, so I'm 1 below, make it 2 below the x-axis. Horizontal stretch times 3, I'm 4 to the right, make it all the way to 12 to the right, because I tripled the 4. Shift left 2 and up 1, put a point right there. And now join all these points together. Now we know that these last 3 are forming a parabola, because these last 3 were the 3 that corresponded to this parabola portion. Draw them appropriately, label your graph. Example 6a. Determine the image of the point 6 minus 5 under the transformation y equals minus 2 f of minus 3x plus 6 plus 4. What this means is this point is on f of x, and it has been transformed by this transformation equation into some new point, some destiny point. Where did this point end up under all these transformations? To answer this question, we have to, first of all, rewrite the transformation equation because we want positive 1x. So we have to factor out the minus 3. And when you do so, you get this and check it. If I were to multiply this out, I would get minus 3x plus 6, which is good. Now we can make a list of the transformations. Firstly, I see on the left, working left to right, that's a reflection in the x-axis. Then it's a vertical stretch times 2. Then it's a reflection in the y-axis. Then it's a horizontal compression by dividing by 3. And then shift right 2 and up 4. Now let's start with this point and apply these transformations to it. So 6 minus 5 goes to under a reflection in the x-axis. Well, we know reflect in x, replace y with negative y. You see, we're putting together all the previous lessons. Reflect in the x means replace y with negative y. So this minus 5 will be positive 5. So we've applied this transformation. Next, bring this point over here and apply this transformation to it. Vertical stretch means multiply the y by 2. So the 5 will become 10. Bring it back, and then apply this transformation. Reflect in the y-axis means replace x with negative x. Bring it over here and apply this transformation. Horizontally compress means divide the x value by 3. So take the 6 and divide by 3. you get 2, negative 2. Bring it over here and apply the final transformation. Shift right 2 and up 4. Well, when you take minus 2 and shift it to the right 2, you're at 0. And when you move 10 up 4, you get 14. And now for the second half of example 6, 6b. Determine the point whose image is 310 under the transformation, the same transformation. So our task is to pull back this point 310. Solution, rewrite the transformation just like we did before. And now what we'll do is we'll undo all of these from the right to the left. We'll have to undo them. Undo an upshift by 4 means shift down by 4, and then undoing shifting right by 2 means shift left by 2. So shift down 4 and left 2. Then, continuing to work to the left here, instead of dividing the x values by 3, we'll have to multiply the x values by 3. So that's a horizontal stretch, factor 3. And then reflect it back across the y-axis. And then instead of a vertical stretch, factor 2, it's a vertical compress by dividing by 2. And then reflect it back across the x-axis. And we will have pulled back the point 310. So let's begin 310 and just apply these transformations because we did them in reverse order. We did the reverse operations in the reverse order and listed them here. So we'll start with the point 310, shift it down 4 and left 2. So down 4, we'll take it to 6, and left 2, we'll take it to 1. So 1, 6. And then bring it over here and apply horizontal stretch times 3. Take the x value and multiply it by 3. Bring it over here and apply. Reflection in the y-axis, replace x with negative x. Bring it over here and apply. Vertical compress by 2 means take the y value and divide by 2. And we get minus 3, 3. Bring it back and apply a reflection in the x-axis means replace y with negative y. And we have our original point, the result of pulling back this image through these transformations. Negative 3, negative 3. It certainly did put together everything that we've learned this unit. I'm not Ziggleby at Bishtung, but thanks for watching. If you liked it, leave a like. If you like the content, then please subscribe. Asking questions in the comment section would probably be productive.